Now that we understand how inverse functions related to each other and how their slopes are connected, let's take the next step. We are going to use that idea to find the derivative of an inverse function. Suppose we have a function f of x that is both differentiable and invertible. That means it has an inverse and we can take its derivative. Then the inverse function is also differentiable. Let's use the graph on the right to understand where the derivative of the inverse function comes from. On this graph, I have the graph of f of x and the graph of f inverse of x. This is the line y equals x. Remember that the graph of the function and its inverse are reflection of each other over the line y equals x. Now, look at this point on the inverse function. The x-coordinate is a, and the y-coordinate is f inverse of a. Now, if we switch the two coordinates, the point is on the original function, and the coordinate is f inverse of a, comma a. On the original function, this is the tangent line at the point f inverse of a, comma a. The slope of the tangent line is q over p. So the slope is actually the derivative at that point is q over p. This is the tangent line of the inverse function at this point, and the slope is p over q. So the slope is actually the derivative of the inverse function at that point is p over q. So p over q is the reciprocal of q over p. So basically, the derivative of the inverse function at a is 1 over the slope, which is 1 over f prime of f inverse of a. The derivative of the inverse function is 1 over the derivative of the original function evaluated at the matching point. Now, let's write this idea more formally. This is called the inverse function theorem. If y equals f inverse of x, then dy over dx, which is the derivative of the inverse function, equals 1 over the derivative of the original function evaluated at f inverse of x. Sometimes we rename the inverse function. Say, if we let y equals g of x, and g of x is the inverse of f of x, then g prime of x equals 1 over f prime of g of x. It's the same idea, just different notation. Let's turn this into steps you can follow. To find the derivative of an inverse function, step 1, identify the original function f of x. Step 2, find the derivative of f of x. Step 3, substitute using the inverse. So plug in f inverse of x. Step 4, take the reciprocal. This formula might look complicated at first, but it really just comes from one simple idea. The slope of a function and its inverse are reciprocals of each other. In the next part, we'll start applying this formula to actual examples.